Ooh. I think 7th period's still sleeping right now.
Yeah.
We're up at question number 64. In the diagram below of triangle BCD, it tells us that DB is extended to A, and it wants to know which statement must be true. Well, we know that the exterior angle theorem is this angle right here. I'm going to call it angle 1. We know that the measure of angle 1 equals these two smaller angles. Okay, and angle 1 is really angle ABC. So this is information that we know based on that theorem. And we've talked about that before because we know that a triangle has 180 degrees, a straight line has 180 degrees. So that's why we know this angle has to be what these two angles are because they both have this little angle in common. So let's see. Is the measure of C bigger than the measure of D? Well, we don't know that information because this could be 30 and this could be 50. All we know is that when we add these two angles up, it equals the outside angle. The measure of angle D is bigger than the measure of angle ABC. But we know that's not true because we know that ABC is comprised of D and C, so it can't be choice 2. The measure of angle ABC is bigger than the measure of angle C. We know that's true because we have to add on whatever D is. So that's our answer, choice 3. For it to be choice 4, this would have had to be an equal sign because that's what the formula is. The formula is that they're equal. Going on to 65, it says, what is the measure of each interior angle of a regular hexagon? We know hexagons are 6-sided figures. I told you, I don't expect you to see this in Georgia, but just in case, that what we do is we count how many triangles there are inside. There's 1, 2, 3, 4 triangles inside. How many degrees are in one triangle? 180. So if we do 180 times 4, we know that the entire hexagon has 720 degrees. How many sides are in a hexagon? 6. So when we divide that by 6, yeah, for sure. Yep. You can never draw it from one vertex to get 6 triangles, though.
Okay. Are you seeing?
Hold on. And then we do that divided by 6, and we get 120 degrees per angle. So let me say that one more time. What we do is we draw the shape. It says it's a hexagon. The way that we can determine how many degrees are in a hexagon, the official formula is n minus 2 times 180, which is you take the number of sides and you subtract 2, and that gives, and then you multiply that by 180. What I like to do is once I draw the shape, I draw how many, I pick one vertex and I draw all the lines to count how many triangles there are. Well, there's 4 triangles inside of a hexagon. Each triangle I know is 180 degrees because there's 180 degrees in a triangle. So I took 180, multiplied it by 4, and I know altogether there's 720 degrees in the hexagon. Now, one of the questions that you've already done, it asks you what's the sum of the degrees inside of a shape. I think it was a pentagon, and that was 540. This wants each one. So because there's 6 angles in a hexagon, I took the total 720 divided by 6 to learn that each angle is 120 degrees. Number 66, it says the volume of a rectangular prism is 144. The height of the prism is 8. Which measurements in inches could be the base? But we know that on the formula sheet, you're going to see BH, where the big B actually is the length times the width. So if I plug in 144, I keep my big B, and then I multiply that by 8. Well, I have to divide both sides by 8 to figure out how many inches my big B has to equal. So 144 divided by 8 is 18.
Where did you get these equations from?
That's on the formula sheet. That one's on the formula sheet. So now I know I have to see which one of these is going to give me 18. Now look, here's the trick. They put 9 by 9. 9 plus 9 is 18, but that's not what we want. It's area. We have to multiply. So it's literally trial and error. 3.3 times 5.5 equals 18.15. I don't know if that's going to be the correct one. I doubt it. 2.5 times 7.2. That's 18 exactly. So it's choice 2. So again, the formula on the formula sheet is this one, where the big B stands for the base, so the length times the width. So I took this out to find out how much my big base had to be, and then I multiplied each of these together to see which one of them gave me 18. And when I do 2.5 times 7.2, I got 18.
This says B times 8.
This says B times 8, yep. I wrote an equal sign and screwed up, so I could make a bigger dot. 67. In the diagram below, AB is perpendicular to the plane AEFG. So I'm going to color this plane in. And this says it's perpendicular. So which plane must be perpendicular to AEFG? So I'm going to kind of color it. ABCE is this plane, which I think is the right answer. It is the right answer. It's number 1. And it has to be that plane because it has to touch the right angle. So that's why it's choice 1. Even though BCDH, that's all the way down here. So that would be parallel, not perpendicular. So that's why it's not 2. CDFE looks perpendicular, but we don't know it is for sure because there's no right angle. The only thing that has a right angle is this plane. And then the other one was HDFG, which is the other side, which again is not touching the line. So it's really important that it touch the line. So it's choice 1. Okay. Excellent job, 68. If you have questions, definitely ask. It's totally fine. Am I going too fast? Okay. In a parallelogram ABCD shown below, diagonals AC and BD intersect at E. So we know it's a parallelogram. That's good information. Which statement must be true? Again, let's see. If it's a parallelogram, we know that the diagonals bisect each other. And we know that the opposite sides are congruent. And we know that the opposite angles are congruent. And we know the opposite sides are parallel. That's the only thing we know about a parallelogram. So AC, which is this line, and DB being congruent, that is false. That is only true when it has to be a rectangle. So if you remember when you make paper airplanes, the diagonals are the same. Angle ABD, so that's this angle right here, is equal to CBD, which is this angle right here. Well, you can tell by the picture that's not true. That's only true when it's a rhombus or a square. A rhombus or a square, the diagonals bisect the angles. So it's not choice 2.
So we have to remember the shapes.
Yes. Correct. Yep. That's on one of the things to remember papers I gave you. Okay, now we have angle AED, or triangle AED. So here's triangle AED. Is congruent to triangle CEB, and that is true. And it's true because the diagonals bisect each other. So AE and CE are congruent. DE and EB are congruent because diagonals bisect each other. And these sides are congruent because opposite sides of a parallelogram are congruent. Okay. The other one was DCE and BCE, which would have been this triangle and this triangle. And I think you can tell just looking at it, they're not the same. Next one, I think we've done this before, but we'll look at it again.
Is it 4?
69 is not 4. It's 2. Which one maps? It's a glide reflection. It's a glide reflection because first it reflected on the x-axis and came to here. And then it translated. So that's what made it a glide reflection.
So
In order for it to be 4, it would have flipped. The T would have been this way. then it would have been a rotation.
Wait, you think it rotated first?
No, it reflected on X, and then it translated over. I was saying it would be this line if it was a rotation.
So, black reflection is when it reflects first and it translates?
Or translate then reflects. But it's 2 in 1. It's just one term for two things. So glide reflection is a translation and a reflection in any order.
So it's not a glide reflection, it's a rotation.
Correct. Correct. It's not a glide reflection if there's a rotation. And if it was just point J and there wasn't a point T, it could be a rotation of 180 degrees. But because the T went the other way, that's why it's not a rotation. It's a glide reflection.
So what if one of the answer choices like glide reflection, then rotation? Is that a trick question?
Not necessarily, but glide reflection is not really a term we use in Georgia. It's more a New York term. So it probably would hit listed as translation and reflection as a composition. 70. What is the slope of the line that's perpendicular? So this is something I really didn't talk about because there was a lot of stuff in this unit. The one way I showed you is set this up into y equals mx plus b form. So because we have x plus 2y equals 3, we can subtract x from both sides. 2y equals negative x plus 3. Divide everything by 2. So we're left with y equals negative 1/2 x plus 3/2. So that's the way I've taught you, and that way will always work. But there's another way I really didn't show you. And so I'm going to show this to you right now. It's not an ERIC hack. It's like a real geometry way to do it. This formula here, the x plus 2y, is really this. And you have seen this before. What I didn't show you is that the way that you get the slope from here is you take the opposite of the A and you divide it by whatever B is. So in this case here, my A is 1 and my B is 2. So it's B negative 1/2. I showed this to you like one day in the computer lab. So either way, that's what the slope is. Because this says perpendicular, we know that we need to do the what? What's perpendicular? Opposite reciprocal. So which one's the opposite reciprocal of negative 1/2? Yep, positive 2, choice 2. Okay. Number 71. It says plane A is parallel to plane B. So I'm just going to draw it like this. These are parallel, like the top and bottom of a cube. Plane C intersects plane A and plane B at M and N. So this would be like where the intersection would be. Here's M, here's N. And then, so that means that lines M and M have to be, what does it look like? This line here and this line here. Parallel. Yeah. I don't know if you'll get one written like that in Georgia. Because remember, these questions I pulled from New York State's test. Basically, because the two planes are parallel, that means that any line on those two planes are also parallel to each other. 72. It says, here's another one that says perpendicular bisector. So which equation represents the perpendicular bisector of AB whose endpoints are this? Oh, fun. Okay. A206, that would be our A and our B. Okay, so first what we're going to do is let's find the midpoint because it says bisector. What's the midpoint formula? Because this one you have to have memorized.
It's x1 plus x2 divided by 2.
Exactly. So remember, you have to know that the midpoint, we add the x, divide by 2. Add y, divide by 2. So first we're finding what's the midpoint. So that means I'm going to have 8 divided by 2, 8 divided by 2. So my midpoint's at 4, 4. Then I need to get the slope of this line so that I can get what the perpendicular would be. So the slope of this original line, this is like a really hard, this might almost be DOK3, but it looks like a hard 2. Remember, slope is we subtract the y's minus the x's. So I'm going to do 6 minus 2, 0 minus 8. That gives me -4/8 or -1/2. So that's my original slope.
I thought it was y2 over. I thought it was y2 minus y1 over x2 minus x1.
It is 6 minus 2 over 0 minus 8.
Oh.
We good? Okay.
Wait.
And the add went for the midpoint. And now this one is we're doing slope. So now that it wants perpendicular, I know I need to do the opposite reciprocal. Right? So my opposite reciprocal of this is +2. So my perpendicular slope is 2. So I know it's not going to be choice 2 and it's not going to be choice 3. So now I know it's either going to be 1 and 4. But the catch is that it has to go through this midpoint. Because it has to go through the ba. I almost said ba. I almost got a southern draw. So now we have to plug 4 into the equation. So we'll see here. Well, if I put 4 equals 2 times 4 minus 4. Does that work? 4 equals 8 minus 4. It does. So the answer is choice 1. Yep. If I put it in here, I would get 4 equals 8 minus 12. 4 equals -4, which is not true. So basically the two things I did. First, I found the midpoint because I know the midpoint has to be on the line. It wants the perpendicular bisector. So I found the bisector first. Then I found the slope of the original line and found what slope would make it perpendicular. I eliminated those choices so I knew where to put the midpoint. Technically speaking, if you wanted to, before you did slope, you could plug 4 into all 4 of these and see which one works out. 4, 4.
Oh, you used the midpoint.
The midpoint. Yep. 37.
73.
Oh, sugar shoots. Wow, that was a dyslexic moment. 73. Or dysgraphia moment. Dysgraphia. Okay, here it says parallel. All right, I'm going to show you the trick because I want you to get used to it. Whatever is in front of the X is A. Whatever is in front of the Y is B. So that's the slope here is the opposite of A over B. So the opposite of +3 is -3.
The formula is AX plus B.
The formula is AX plus BY equals C. And A is always touching the X, B is always touching the Y.
Is that supposed to be also the slope formula?
Yes.
That's another formula you can use. I showed it to you one day. The other way you could get the slope is to do it how we always do it.
Yeah.
Which is we subtract 3x from both sides.
So -3
and then divide. So either way you can do it.
But then we have to find the slope.
Right. And then from here you know the slope is. So now this says let's finish this one question. Let's finish this one question. Let's finish this one question, then we'll take the brain break. So here's -3/2. It wants parallel, so I know my slope has to be -3/2. So I'm going to eliminate 1 and 2. Because it says it has to pass through the point 2, -1, all I'm going to do is substitute it in. So I'm going to put 1 equals -3/2 times 2 minus 2 and see what happens. 1 equals -3 minus 2. 1 equals -5. That's not true. So it can't be choice 3. It's got to be choice 4. Okay.
Wait.